As you know, I'm Rahat, and I'm a software dev engineer at Ian. And today we are going to have a little chat about security, cybersecurity. Why do we need it? Do we need it? Can we afford to ignore it? So, why? Well, other than the fact that my boss made me do this, so much of our information is up on the internet. We have our credit cards, our metadata, we've got our addresses, our personal information. Facebook knows so much about us, even if you don't use Facebook directly. All our metadata is on there. And so you want to secure that down. And you really have to think about how would it be if it was your information that was on the internet and lost, leaked, or taken somehow. So there's a lot of information we need to secure it down. And you might think it's not that much, but I've got a list here of some of the breaches that have happened over the last 12 months or so, slightly longer. I'm going to name and shame Yahoo here because they have been terrible. Am I blocking the screen? So not only did they initially lose 500 million in September last year, then they had another hack, and at first we thought it was 1 million, but last month they confirmed it was all 3 billion of their users who they had up until 2014. So they've all been compromised, and that's terrible. That's just not in today's day and age. But if you look at this list, it just goes on, and this is not even a complete list. So there's a lot there, but really, how much are we talking about? I mean, we've got big names there, but how much? There's this nice little website called Breach Level Index, which is powered by a security software company called Gemalto. And they say over the last couple of years, we've lost about 9 billion records. And that's a whole lot. That's 60 per second. And not only that, but if we look at the map of the UK, we've lost 137 million. There's about 66 million people in the UK, so that's 2 records per person. So that's a whole lot. And if you take a look at this little statistic here, only 4% of the data lost was encrypted, which meant only 4% of the data lost was rendered useless. The other 96% is up for grabs by the attackers. So, yeah, we should protect ourselves. And it's kind of daunting. If the biggest companies like Yahoo can get hacked, how are we going to protect ourselves? Well, we're not aiming to be impenetrable. That's actually a myth. It's not possible. That's why even the biggest companies get hacked. I mean, if you're being attacked by a state nation, good luck. But what we're aiming to do is ensure that the cost of breaching our information is higher than the value of the information we hold, because that will not seem worth it to the attackers. And a really good and simple way to start is HTTPS. And it might seem obvious, but there are reasons why. Has anyone heard of a Wi-Fi pineapple? A few of you. So it's this cool little device on the left. It looks like a router, and it essentially is a rogue router. What it will do is you can take it with you. So the phone in the middle is hooked up to the Wi-Fi pineapple, and it's connected to the internet. And what this pineapple is doing is it's broadcasting SSIDs of every device that's trying to connect to an SSID. So if an SSID is saying, hey, is my home network here? This Wi-Fi pineapple will say, yes, I'm here, and tunnel you through. And it will capture your traffic. So on the left, you can see a whole bunch of SSIDs that the Wi-Fi pineapple is trying to be. My iPhone's here. My home network somewhere up there. And it's really easy to see how many you've captured, how many SSIDs you're broadcasting. And it's crazy. And with this, it's just so easy to see people's unencrypted traffic. So over here, you see this phone is browsing on a website, and on the web portal, we can see all the information, all the URLs they've hit, and all the images they've loaded. And that's because it's over HTTP. So we should probably at least start with HTTPS. And it's getting better. A couple of years ago, the HTTP traffic was really low, like 13%. And at the start of this year, we've gotten up to about 50%. Better, not good enough. We need to make traffic encrypted for everyone, for every website. And thanks to new technology, HTTPS is now not slower. So that was HTTPS, and this is HTTP. The reason the HTTPS one was so much faster here, because HTTPS allows us to use a new HTTP2 protocol. And with that, we can make our chatty websites a lot faster. On the note of HTTPS traffic, this is a graph of HTTPS traffic tracked over a Chrome browser, which Google released recently. And they can also see a significant increase in HTTPS traffic, which is good. But this is just one browser, and it's still not 100%. So not only is HTTPS good, but what we also want to do is a few other really easy quick wins. There's content security policy, which is a header you set on your devices, on your servers. And what this allows us to do is whitelist content sources that we trust for our scripts, our media, and the like. So we will whitelist URLs and domains that we trust, and we can only load our information from there. If you set your cookies to HTTP only, that will mean JavaScript cannot access your cookies, which is very useful in defending it against XSS attacks and the like. If you set your XSS protection to mode 1 and block it, what it does is it ensures that not only will we not try to sanitize our inputs when XSS is detected, it just won't try to render the page, which is a lot better than just setting it to 1, because that will try to sanitize a web page, and some people have tried to work out how the browsers sanitize web pages and attack those. And then there's your content type options. Setting that to no sniff is just saying, hey, we really trust the developers and we know that they've expected the right MIME type on the servers. Tell the browser not to try work out what MIME type the application is rendering. This is useful so that if a malicious user is trying to upload an executable, it's not going to try work out and execute what it is. Frame options is a really important one, because it stops your website from being iframed by another website. If you deny frame options or set it to your own domains only, what it means is that only your own domains can iframe yourself. Otherwise, another page can take your website, plant it there, and then hide it with CSS and essentially clickjack you. And HTTPS strict transport security is a very good quick win. Sorry, I'm kind of blocking the thing. Strict transport security is just ensuring that your browser is only connecting over HTTPS to your website. It will not try to make a HTTP connection at all. And getting SSL certificates to go to HTTPS is actually very easy now. There's a nice little site called Let's Encrypt, and they serve free SSL certificates to anyone who needs it. They are short-lived, but they're better than nothing, and they're good for proof of concept if you've not gone HTTPS yet. And once you've started implementing HTTPS, you can use a nice little site called SSL Labs to test the implementation. It will tell you what's weak, what needs improvement, and what's good about your implementation. So, an interesting story about a project I worked on in the past. So we were developing a single-page web app which spoke to a Dropwizard's Java stack, and it was an Angular frontend. It was all an internal product for a whole bunch of internal users. So we thought, that's fine, that's easy to secure. We'll use HTTPS to connect from the client to the backend. It's all internal, that's safe enough, that's secure. You really have to watch out for the architecture you're working with. So what we found out is we had a load balancer in the middle, which you usually do. So this was an internal load balancer. It was managed by us. And this load balancer was stripping all the HTTPS headers and sending HTTP over the wire. So we had a whole bunch of user credentials going over HTTP because it was a stateless web app. We were sending user credentials each time. So we were sending base64 user credentials over HTTP. Yes, it's internal, but that's still a big security risk. That's a big problem. So we thought about it and we worked out, actually, it's not that difficult to solve. So what we did is every time we built the server, we created an RSA key pair, public and private keys. And whenever a client tried to connect to our servers, we received the public key. Using this public key, we would encrypt the user credentials and send that over for authentication. If the user was authenticated, they'd get back a JWT with claims and everything else. And then they use this for all future connections. And because only the backend could decrypt the token, even if the token was stolen, there was a lot, the risk of losing credentials was pretty much mitigated. And only sessions could only be stolen for a short while. So, better. It was good enough for what we needed because, again, it was an internal application and the client said, actually, this is good enough for our use case. And what we learned was it's always best to assume everything out of the control of your application is compromised. Always assume that only what's in your own direct control is secure or can be secured. Because, again, all it would have taken was one disgruntled employee to wireshark the HTTP connection between the load balancer. And we all know the biggest threat to security isn't the software, it's people. How many people have accepted a certificate like this? Please don't. Because you're probably accepting a root certificate and most people think, oh, it's Twitter, they're sending me a certificate, it must be fine. But it's probably not Twitter. Actually, it's most certainly not. And I'm not going to demo the Bash Bunny because unfortunately I don't have it with me today. But this is another way of getting a root certificate. And I'm going to skip over this, but to explain what a root certificate is it's essentially a certificate at the top of the hierarchy in command, and what it means is that anything served with this certificate will be seen as trusted by your computer. So if you accept one and store it in your certificate chain, you're kind of screwed. Even HTTPS won't save you. So let's not do that. Talking of which, has anyone heard of what Lenovo and Superfish did with their certificates? A few of you. Yeah, again, what they did is they thought, let's put some certificates on the notebooks we sell. They did it for about a couple of months between 2014 and 2015. And the reason they did it is so they could serve ads to you on your secure websites using HTTPS. What they're doing is they were capturing your traffic, putting new ads on the website and sending the website back through to you. And they could because the notebooks that they sold had a self-signed root certificate. What they didn't think about was the fact that they use the same certificate on all the machines. And so anyone who knew what they were doing could find someone with a Lenovo machine and do the exact same man in the middle that Lenovo were using, Superfish were doing to serve you ads, but to steal all your data. So again, you've got to be careful. And that's why security is everyone's responsibility, whether you're a developer or user or even anyone else in the team. So as a developers, we've got to think about writing secure code. And what that means is thinking about security as we develop in iterations. It's not going to be, crap, we haven't done security, let's think about it. No, it's usually, okay, I've got this API, and we've checked that the API only receives strings, but has anyone checked it's sanitized? Has anyone checked for dangerous characters? QAs should think about security when they're testing. Especially product owners. If product owners are not aware of the security risks of doing or not doing certain technical tasks, it's not on them. But if they're aware of it and they're choosing to accept that liability, that's a whole different problem. But we need to make everyone aware there are security issues that need to be spoken about. And that's why we need to integrate security awareness into our daily scrums, into our daily Kanban boards. Everyone needs to have it in mind. Share ideas. Work with other teams. Some people have probably solved security problems. So for example, the solution we came up with for the single-page web app, we shared that with others in our team because they were doing other single-page web apps for the client, and they made it in component, and we all used that component because we had solved the problem once. Please don't leave it to the end. It doesn't work. You can't patch on security. Obviously, you can't just think about security at the start and think it's going to work. Just as architecture grows and evolves with the development of a product, the security concerns of a product will be the same. So that's why you have to incorporate it into your development cycle. You can do this as well by pen testing occasionally. If anyone's heard of the Z attack proxy by OWASP, that's a good tool as well. And think about it, if you leave it to the end, it's essentially tech debt. How many of you have tech debt at the moment? And how many of you are working towards reducing that actively? A few less. So yeah, I mean, start small. This talk wasn't really to make you security experts. It was more gauged at making you aware of the problems. So you'd start small, you'd do it bit by bit. You'd get rid of the low-hanging fruit first, and then you'd think about the more obvious things. It's about increasing the barrier to entry of malicious attackers, one step at a time. And if you're not sure where to start, the OWASP Top 10 is generally a good place to start. Sorry, I'm just aware of the time. So the OWASP Top 10 has actually also recently been updated. So the 2017 release candidate 2 has come through. There's still a few obvious ones, like injection is still the biggest issue. But it's also noted that security misconfiguration is up there. Things like not updating your dependencies. How many of you are completely up to date with all your dependencies? 2 people. So if you're not up to date with all your dependencies, how many of you are at least certain your current dependencies have no vulnerabilities? No one. One person. So again, you need to be sure that you're looking at your dependencies, keep them up to date. Actually, on that note, how many of you are using the latest JVM version? Not Java 9, but as in the latest security update. A few more. So that's another thing to be aware of. When Java comes up with an update, it's usually a security patch. Also on the bottom is insufficient logging and monitoring, especially as we move away from monoliths. You got to make sure you're logging properly and monitoring your stacks. And on that note, has anyone heard of the Equifax hack?
Sorry?
The Equifax hack?
Yeah, of course.
Yeah. So the attackers were in that system for a pretty long time, and no one saw anything. They had quite some time to play around with the systems, elevate their permissions, get access to more systems. I'm willing to bet a little bit that they didn't have enough logging and monitoring. So, yeah, keep in mind, we're not going for 100% security, but a secure system is something that can be considered where the cost of extracting the data from that system is higher than the value of the data itself. Because, actually, security is kind of like meeting a bear. It's actually one of my favorite analogies when it comes to security. So 2 guys are hiking and they come across a huge bear. The first guy, he drops everything and he starts running away. The other guy's saying, what are you doing? You can't outrun a bear. He says, I don't need to outrun the bear, I just need to outrun you. And to be fair, that's how security is as well. the attackers will usually go for the easy targets, because as long as they have data to exploit, that's what they're going to go for. So remember those steps. HTTPS, secure your headers. Please don't accept root certificates. Think about it. It's an ongoing process, and involve others. And look at OWASP. It's a good place to start. And please, let's improve that 4%. That's a really low number. Let's make most of the breaches, at least if we're breached, let's make it encrypted. Thank you.